thank you for coming to the BSCexpo and attending this little presentation. I have to thank also the BSC for inviting me. I couldn't resist the temptation to talk to you about a project that I have just started to work on. It is no secret that in my life I have been working a lot with new technologies, and this is something that I've been doing throughout, past maybe 12 years that I was running a post facility called My Therapy. But this year I decided to, completely throw myself into something that I discovered last year and that I felt is probably the most exciting thing that could happen to color grading and post-production. And I just couldn't resist the temptation to be fully involved in it. What I'm talking about is, of course, AI and machine learning. It is a technology that has been evolving rapidly in the last years. Especially last year, we saw an increase in speed of maybe like tenfold, which just made this technology a little bit more accessible. But there was very little connection between AI and machine learning and post-production, which is no surprise because this industry is usually a little bit late with adopting new things. And AI comes from a little bit different type of data processing. So it took us a little bit to understand how we could use this technology to our benefit. Me being a colorist and color scientist, I have been dabbling in writing of software programs for a while and have also developed several software applications on the way and kind of have tried to understand how we could use this technology. What I'm going to show you today is a little bit kind of an example to how we can use it and what it's going to be able to do for us. This is a color grading system, and this is one I started with. And this used to be in 1990s, the state-of-the-art DaVinci 2K. And this is what the DaVinci looks today. So it actually has changed a little bit in terms of the way how it looks. It looks a little bit modern. But it's interesting to know that inside the machine, what's happening is still pretty much the same type of code. The same software is running still. And what we're doing at the moment in post-production is we are using actually algorithms. And these algorithms have been written many, many, many years ago. We are just implementing them in a slightly different way, but in its core, nothing is really changing. The algorithms are basically mathematical operations that allow us to achieve certain results based off kind of what we're trying to do. So if I do something to it, then something is going to happen. So just to kind of explain to you what happens. So if I have this particular image, and if I kind of say I'm going to now apply a lift of -5, this is the result we're going to get. Then if I apply a gain of +1.5, this is the result. And then if I add some gamma to it, let's say, then I would get this result. So basically, it is all very manual process where we basically sit on the kind of controller, we move a controller, and that kind of creates a result. Now, if you have been working in post-production and have spent many nights and many days sitting on that controller, you probably have asked yourself at some point, is there any way to automate this process? Do I really have to sit here and press this button and move this dial for every single shot? This was kind of the question I had on my mind for many years, and I have actually tried several things, and I'm going to show you what is it possible to do in terms of automation today? What is available inside the grading system? So I'm going to use examples from Resolve simply because it's a kind of most popular platform. But you could imagine there are like some other platforms that are attempted to do the same, but the results are all pretty much the same. So basically, if I start with this raw file and I use Resolve's function of autograde, this is the result that I would get. So basically, it uses some sort of function and algorithm to try to imagine to what this image should look like, or kind of to adjust it based on certain parameters. The next thing, if I was to use Resolve's auto match function, this is the result I would get. So you see, basically, on the right is my reference image, and on the left is how far software algorithm was able to match these two shots. And clearly, it doesn't work. And the reason why it doesn't work is because it is very, very complicated process. There are many, many factors involved in order for this particular process to work. It is not possible for us to write an algorithm or process that would take all these different parameters and options into account and come up with a mathematical formula that would be able to match shots. So, this was my thought. If AI and machine learning is very good at doing very complicated things, then there must be a way how we could use it for this, for example, just a simple process of a primary color correction. So the way, what we did is we started our journey by looking at an algorithm that we were able to analyze and get access to because Google was kind enough to open some of that kind of science that they have put into it, which is the YouTube algorithm that guesses or suggests videos for you. So anytime you click onto a video on YouTube, on the right-hand side, you get suggestions to which videos you should be watching next. So basically, that's a pretty good job. So I kind of put like a video of kind of from our, website, and it gave me really, really very good and close results that are thematically really interesting to what I would want to watch. And you probably noticed that they are very good in guessing this. Another one of these, like a really great examples of this deep learning is Spotify. I don't know, guys, if you have Spotify, but and if you discover there is this Monday morning Discover Weekly playlist, where basically the Spotify gives you a playlist of about 30 songs that they suggest based on what you liked and what you did. So basically, the software companies have become so good in analyzing things and basically going and selecting the right kind of content based on what you wanted to do. So I thought, if AI and machine learning is really capable of selecting 8 videos on a YouTube out of trillion options, then it must be able to do the same for color grading, because in color grading is the same. There is 1 trillion options to how I could adjust or make a look of that image, but for some system to guess which is the closest one that I want, there must be somehow a way for us to achieve that. So this is what we did. So we embarked on a journey to understand how we could use this machine learning and AI in order to assist us in that project. The first thing is we kind of thought like, okay, we're going to go and create actually a concept, which is an assistant software. This software is never going to go and take over color grading as such, but it's going to be something that normally an assistant in color grading theaters would be doing, like doing some matching or grading dailies or something like that. And we called the project Joy. We said, okay, the first thing you have to do is you have to build a bot that builds the bots. So basically, first thing you need to do, you can't build these bots really yourself. You need to build another bot that will be building the bots. So first thing we did is that. We created a bot that builds the bots. The next thing we did is we let that bot build thousands and thousands of other bots. And all these bots were made with a simple purpose to be able to do primary color correction. The next thing you gotta do, you have to build something which is called a teacher bot. Teacher bot is not really a teacher, we call it a teacher, but what teacher bot really does is not teach the bots how to do their work, but test their work. Because you think about it, if this teacher bot would be able to teach other bots, then the problem would be solved. We already have a bot that knows what they're supposed to do. So all we can do is we can tell teacher bot when the results are good or bad, and then the teacher bot will be able to analyze work of the other bots. The next thing then was, okay, let's go and train this teacher bot for it to understand how it's possible and how actually, the results that bots will be creating are good or bad, or how it is going to match perfectly into what we're trying to do. For that process, we have taken a sequence and basically we started grading. And this is how it works. You get bot to suggest a color grade, and then colorist takes it and corrects it if it thinks, okay, this is not quite what I want. So basically, you would then go to the next shot, suggest, correct, and so on. This process is called passive learning. This is the absolute secret of machine learning. This type of learning process, and like where a human actually has to guide a bot or a teacher bot to understand to what the real results are, is really where it's all happening. If you have, for example, thought, why is it that Google gives me unlimited storage for my photos, is one of those reasons, because they need your photos in order to be able to train their machine learning and their image recognition processing. Also, I don't know if you have recently tried to sign up to some of the websites and they say, oh, we need to check that you're human. Can you please click on the images that have a traffic signs in it? And did you notice that suddenly all we are clicking on is a traffic signs photos? So why do you think that is happening? Why do you think they're asking us to recognize traffic signs? And who is going to benefit from that? You probably understand that the self-driving vehicles is actually the next thing where the AI and machine learning is going to be, and how important it's going to be for those vehicles to be able to recognize the traffic signs. So what we all are doing actually is we are slowly contributing. We're doing exactly that, a passive learning process of helping bots improve their process of recognizing things. And this is all bots are good in doing. They can do one thing. You can, for example, teach them to recognize a number or recognize things. And sometimes you can inherit some of this. Actually, the way how it works is following. We analyze the data between what bots suggested and what the colorist or human did. And you see this graph is showing the amount of errors or the amount of changes we had to do on every shot. And as you could imagine, it was absolutely horrible when we started with, right? You see the amount of errors was like so big. I mean, the bots were completely off the mark. But they have very quickly recovered and started to follow and started to kind of understand in which direction we want to do it. At least a little bit in a kind of wider sense. But there was still a lot of error. Pretty much on every shot, we had to go and correct and figure out what is going to happen and how things are going to work. We had to correct every single shot. So we didn't really, at the beginning, get good results at all. But we felt that it's improving. There was a certain tendency for that. Once we have kind of went through one cycle of learning, what we do then is we take this teacher bot to go and analyze the performance of the bots, of these thousands of bots. And then you do another so-called a cycle. And what happens is this. Only 2% of top performing bots, of those who were able to guess the look in the best way, survive. 98% get recycled and they get rebuilt based on the 2% that were very good performers. So what happens is we are narrowing the results. We are narrowing out of thousands and thousands of bots, we are narrowing to only 2% that we think are the best performers. And then we go and we process it again. We let them again guess the sequence, we teach them again, and then we let them analyze the results again, and so on and so on and so on. Now, why are we able to do this today, and why is machine learning improving so much is exactly for the reason. 4 years ago, roughly, one cycle of training for the system to be able to process our data, analyze and teach basically the other bots what's happening and do the testing would take about 20 days of a machine that would cost, it would go well into the price tag of a supercomputer. So basically it would take about 20 days to do this kind of processing. Today, it takes about 5 hours. 5 hours, and you don't actually need to kind of, even rely and buy, this massive hardware. There is a lot of, ways how you can develop these things in a much more practical way. What we got now is a basically ability to be able to train our bots very fast. So we don't really want to kind of, say, oh, we're happy with the results we get. No, we want to keep improving. So what we decided to do is we decided to do about 50 cycles of learning on this particular sequence. So let's see how far we're going to be able to get them to learn and to guess what is the right primary color correction for this particular sequence if we are to go back and only keep the 2%, recycle them, let them teach again and again and again and again. This is the results after 50%. As you can see, it was pretty flawless. Those blips that they do, they usually happens on a scene changes. So basically, every time there is a scene change, we have to go and adjust a little bit more, and then, the system is actually very, very, very good then in guessing and understanding what would colorist would have liked to have this primary color correction to look like based on the reference shot, on the reference image that we have started with. Based on these results, we have realized that actually it is going to be possible to teach a system or a bot to basically help and assist colorists in this process, to basically get a much better way of finding and what would have been the primary color correction, to match shots quicker and so on. And we spend a lot of time in the grading theater of doing that. And you know, I don't know, like, you know, how much time and how much money this is going to save us in the future. But in any way, what is going to be absolutely fantastic is to have this button that you can rely on, and that is going to give you a very, very accurate result of how you're going to be able to match things. But this was only scratching the surface, because when we realized, you know, that the ability of machine learning to recognize what is in the shot exists, and possibility, you know, for us to be able to work with that type of processing and machine learning, we have actually realized how much more is there that could be done with this process that could, you know, help automate and speed up the color grading process. Next year, I would like to demo you the working version of basically Color Lab Joy, which is going to be the kind of what we think it's going to be the first kind of deep learning and machine learning assisted color grading system that will help, you know, improve this particular process. In the meantime, if you guys are into color and you are colorists, I would like to invite you to go and explore tools that we have developed today for you know, color grading that are doing exactly the same, but you know, without use of machine learning. This is like a learning that, you know, human learning. This is basically something that took us about 12 years of experience to figure out how we can improve the process of color grading. So one is the Color Lab RGB, which is a great look development tool that is going to help you to create fantastic looks and be able to communicate these looks. By the way, these are all plugins for DaVinci Resolve. Then we have one plugin which is called Color Lab HDR, which simplifies the HDR grading process immensely, where you're basically able to deliver to both SDR and HDR in parallel. You're able to grade in DaVinci for both at the same time. You're able even to archive for later repurposing, even if you're not going to deliver to HDR today. You know, in the future, you can create an archive that you're going to be able to extract the HDR master from. Also, we got like a 360 plugin. So, you know, you saw it. The 360 is a fantastic medium, but at the moment, really, it's impossible to see what something's going to look like inside the VR headset when you grade with DaVinci. And we have worked in development of plugin that is going to allow you to use VR headset in real time and be able to see what something is really going to look like when it's in the headset. A very, very useful thing for any of the VR filmmaker. And then also there is a Color Lab Aces. So anybody who's actually wanting to create their own custom looks profiles, LMTs or lookup tables for Aces, are now able to use that plugin to do so. So these are actually at the moment, you know, there is about, I think, I would say about 400 users out there that are using this software. They are primarily, you know, people that we worked with, or, you know, cinematographers or facilities, or, you know, companies or DITs that we worked with. So we haven't necessarily released it to the public, but we are going to do this very soon. But if you are interested and you want to start using them now, just go to the website colorlab.co, and there is a little place where you can just register, send us your email, and we are going to send you information to how you can get access to that software. We are not really, like, you know, ready to kind of push it publicly to the outside world. But, you know, if you're a cinematographer, filmmaker, or a colorist or anything, and you need some of these tools to help you, we'll be happy to, you know, get you access to them.